Hi friends, welcome back. Today we are going to solve a problem, find area of largest square in matrix. So we are given a binary matrix with zeros and ones, and we have to find out the largest square formed by using ones. So for example, we are given a original matrix here, like which is a 6 by 6. It is a 6 rows and 6 columns, and we are asked to find out what is the size, like what is the area of the largest square. So every one is counted as a square of area 1. So for example, if you look at this one, then this is a square of area 1. Then if you look at this orange border square, this is the largest square in this matrix with a area 3 by 3. So the area is 3 by 3 means 9. So as you can see, it's a 9 ones, and this is the largest square in this matrix. There are some other squares with, you can see, like this 1 1 1 1. So this is a square 2 by 2 with a area 4, but this is not the largest square. So we are interested in finding the largest square in the matrix. So how can we find this actually? So we are going to use a dynamic programming technique where we will create a DP array of the size, same size as the original matrix. So if the original matrix is 6 by 6, the DP array will also be 6 by 6, and we will keep populating the DP array from the original matrix as we traverse the original matrix. So first what we are going to do is we are going to keep the first row and first column of the original matrix same in the DP array. So as you can see, this is the first row, 0 1 1 0 1 1, right? So here also it is 0 1 1 0 1 1. So we will be keeping the same as the first row, and the column also same in the DP array. So it is 0 1 0 1 1 0, right? 0 1 0 1 1 0. So this column and this row we will keep same in the DP array. So at the same time, I will be discussing the from this diagram. I will be showing you the implementation as well. So here, as you can see, we took a DP array. It is the same row and same columns as the original matrix, and we are first populating the first row and first column. It is the same as the original matrix, right? And then once we are done, then we will start iterating the original matrix from the index 1. So 1 1 cell we will start iterating. So we are here, so we are at this cell which is a 1 1 cell. So what we are going to do, how we are going to populate the DP array is, we will look in three directions: this upward direction, this left side direction, and this diagonal direction, and we will get the minimum number from these three elements, and we will add 1 to it. When we see a 1, we will do that. If we see 0, we will just keep 0 as it is. As you can see, 0 we see here, so we kept a 0 here, same. But now when we see 1, we will look at this 1 0 1. So 0 is the minimum element, so we will add 1 to it, so it becomes 1. So it becomes 1 into the DP array. So similarly, if you look at this highlighted orange color, orange color square, then as you see here, it is 1, because here, like the minimum element is 0 here, so we kept it 1. Here also we have 1 because we have a 0 here, so we kept it 1 here. Here it is 1 because we have a 0 here, so 0 plus 1 is equal to 1. So for example, if we are at the I and jth cell here, then we will see in these three directions, right? 1 2 3, so which is I minus 1j, I minus 1j minus 1, and I j minus 1. So these three elements we will look, and we will take the minimum of it, and we will add 1 when we are having a 1 in original matrix. So so for example, now when you can see this one as a highlighted in a pink color, right? So when we are doing a DP array for this element, we will see 1 1 1 here, so we will have to add 1 plus 1, which is 2 here, right? So that's why we have a 2 here. And the 2, it makes sense because this is a 2 by 2 matrix now, right? If you see this, then this becomes a 2 by 2 square. Basically this is a 2 by 2 square, that's why 2 came here. And when you are looking at this green color one, then when you look at like in the DP array, when you look at the three directions here, you see 2 2 2, right? So you will add 2 plus 1, which becomes 3, because this one is a 3 by 3 square now. So as you look into this highlighted, this is a 3 by 3 square, that's why 3 came here. And that's how, you know, we will keep when we are doing the populating DP array, we will keep track of the maximum value we have seen so far. So maximum value we have seen is 3 here. So you know, this is the same logic that we have discussed, that we will look at the 3 directions. These are the 3 directions that I was talking about. So if we are in the ij column, ij cell, then we will look into these 3 directions, right? I minus 1 j, I minus 1 j minus 1, and I j minus 1, and we will take the minimum value from that value. As you can see like this, mat dot minimum, mat dot minimum. So I will take like mat minimum value into dp of ij cell, and then I will also take this square length variable I created to get the maximum square length we have seen so far, which is 3 in this DP array. So we will capture 3 here, and once we are done, at the end we will just return square length into square length, because if 3 is the length, then the area will be 3 into 3, which is equal to 9. So that's how we will find out the largest square in the given matrix. So this is the same matrix that we discussed. I took it here in the example. So let's give it a run, and it should give us the 9 as the largest area. So 9 is coming as the largest square area here, so it is correct. So this is how we can find out the largest square in the given matrix. So we will just use a DP array of the same rows and columns as the original matrix, and we will populate the DP array as we discussed here, and we will just, you know, return the square length, the maximum square length that we found during our matrix traversal and population of DP array. So this is how we can solve the problem of finding area of largest square in matrix. If you like this solution, please subscribe to my channel and click on the like button and hit the bell icon, so you will get the notifications for future videos. Thanks for watching the video.